Do you have any bites? Oh, no. Yeah.
Got one. We're on. We're on. He's off. He's off. Oh, what? He's on. Dave, I got a good one. So welcome back. If you followed the first tutorial, this one we are going to take off where we stopped, and that was at 3D modeling, and right now we need to get this thing set up for the printer. So there's something I forgot to mention in the last video, and it was pretty crucial, and it was around this reference shape. If you got the starter pack, it came with this model here of a lip. If you go to my website, let me just pull this up, allinclusiveangler.com, and the lure build tutorials link, go ahead and go to the lipless crankbait, and if you take a look at the table down here under hardware, you'll see a hyperlink for C1 circuit bill lip. If you click on the link, it's going to take you to lurepartsonline.com, and if you can see this here, it's a C1 lip right here. And if you're following my design, you're going to want to order a pack of these, and you just click on 1C and you get 10, I think, in a pack, and it's only $3.86, so that's not a bad deal. And so if you go back, you can see the model is the same shape as that lip, and because that's what we're going to use as the lid. So before you export, go ahead and go to Windows, Settings, Plugin Manager. Under Search, type in STL. Go ahead and make sure your STL translator bundle is loaded, and click Auto Load, and then refresh. Close. This is going to allow you to export this as an STL. So select this object first, go to File, Export Selection. Make sure you go to your destination. I'm just gonna probably go on my desktop, and if you need to change your file type, just click here and go to STL Export. Give it a file name. I'm just gonna call it Lure. Export selection. Okay, so we have our slicer program open, and it gives us a view of the print sheet if you're not familiar with this. So we get kind of a 3D view. We can just click and drag and check things out. These are my default settings right here. We're just going to keep those playing right now. And let's click and drag our lure STL file onto the canvas here, or the print sheet. Okay, so it brings the shape on the print sheet just kind of randomly, and we obviously can't print it just like this. If I were to hit slice and just keep my defaults on, it'll generate something and tell me that it's gonna work. See, it doesn't really throw up any errors or anything, but you don't really have any surface area right here to grab, so it's gonna fail pretty early on. I would say if you're gonna try to go right here with no supports, it's going to fail right around this point. It's just gonna fall over. The printer is gonna sit here and circle, and this is gonna shake and fall over. So we can't use this. And if we go back to the 3D view, and even if I turn on the brim and hit slice, that's still not much contact area, and without any support, it's gonna fail. So let's try to get this print supported a little bit better. Slicer does have built-in support systems, so if I go to supports, support on build plate only, and hit slice, you're gonna get this. It's gonna generate these temporary placeholders. That's gonna help support your model a little bit better. Now you might be able to get away with this. What I found is that if you still don't have enough surface area down over here, it's still gonna rock when it's printing, and you're gonna get some layer shifts. Because if you take a look at that support material, it's just barely touching. So you still might get some rocking. You can give it a shot, and even with PrusaSlicer 2.6, you can use tree supports. They're kind of like organic supports. They look a little bit different. I'm using PrusaSlicer 2.5.1 right now. It's a little bit more stable. So I'm using the current support system that comes with it. Now this isn't our only option. We can play around with the position of the lure and try to get our best. And sit here and try to get our best position possible. So if you look at it at this point, it still doesn't give us more surface area. Almost no matter what you do, you're not going to increase your surface area where it's grabbing on the print sheet. That's just not going to work. So what can we do to get a cleaner print without failure? Well, we can try to 3D design our own supports. And if we go back to Maya, take a look at your model, and then rotate it with the rotation tool. And I kind of like this orientation, so we're going to go with this. You may want to play around with this however you may see fit. I'm going to add one cylinder, so go to Modeling, Polymodeling, select a cylinder. And let's go ahead and change the rotation on it until it lines up kind of like a pillar, and scale it down a little bit and line it up with the front end of the lure. Let's just go ahead and duplicate this cylinder. And when we position the cylinder, let's go ahead and copy the translation and paste it so we get a symmetrical placement. Select the two cylinders in the back and combine them. Mesh combine. And let's select the faces on top. And there's a quicker way to do this. I didn't turn on the symmetry. Once they're all selected, you may notice that you selected too many faces. So go ahead and deselect any if you did. Let's go ahead and click and drag it. And we want to drag them up until they kind of stake into the body of the lure. Alright, that looks pretty good. Select the front cylinder, scale it down a little bit, and we're going to just kind of refine the placement. And we just want to position it so that it's going to properly support the front here. Let's go ahead and add a cube. And this is optional. You can print the cylinders on the print sheet as is with the supports when we get there. But for this design, I just went with a good surface grab on those pillars. I wanted to connect them all, so I added a thin rectangle. So let's select all three cylinders, mesh combine, and select the faces. As you can see, I selected too many again, so I'm going to deselect them. And I'm just going to click and drag them up until they're buried into this shape. Now I'm looking at the pillars in the back and they seem like they might just be too thick. So I'm going to scale those down. And I'm also going to click and drag and widen the placement. Don't forget to copy the translation so that you keep it symmetrical. And let's combine them. Let's go to face mode. So I think they're just a little bit too thin and I want to widen them at the base. With those faces selected on the bottom, I'm going to click and drag them up. And go to extrude. And let's scale them out. As I'm scaling them, I'm keeping them on one axis, because I'm just trying to make that base wider. And once I get the width I like, I'm going to extrude again and click and drag it so that it's buried into that shape again, your base. So that looks pretty good. I might just widen out this base a little bit. I might also widen those pillars out. So with both pillars combined, let's select the faces here and scale them out on the same axis. You can go ahead and combine them if you want to. If you get an error when you combine them, you can just leave them. They'll probably print okay. Usually PrusaSlicer will correct any errors when you import the model. At this point I wouldn't worry about it too much. So let's raise the pillars up a little bit, select the faces, use the move tool, and get them as close to the body as you can. Don't make sure they don't overlap. That looks good. And now let's export it. So let's combine the whole model with the supports. So click and drag selection and combine. And go to file export. Let's export our model. And now that we imported our model into PrusaSlicer, you can see it just brought it in there upside down. Go to the face selection and click on the bottom underneath the base support. And now it drops it how we want it. And if you take a close look, something I noticed is that it may need additional support even with the supports we modeled in. It's got a big gap there where it's going to be printing a lot of overhang, and that can lead to failure. So I'm going to add some additional supports in there. Even inside the lip here, you can see it's got some bridging it's going to have to do. So we need to better support this, and there's an easy way we can do that and make a custom support here in PrusaSlicer. So let's right click our model and go to support enforcer, and let's add one. And it just brings in a cube, and we want to line it up with the lure. I'm going to scale it in, and you want to squeeze it in enough so that it's not protruding out the eye sockets. And that looks pretty good. And I want to make sure it covers the front and back, and it does. So now if we hit slice, it's not going to generate anything, so we have to go to supports and specify that we want it for support enforcers only, and hit slice. And this looks good. I might just run with this. But to get a better idea of how it's going to print, let's go ahead and take a look at each layer, and let's slide it and let's take the slider and bring it down. And so far it's looking pretty good until we get about right here. Now if you take a closer look, you can see it's going to print some support material inside one of our inside one of our chambers where we're going to screw in a screw eye. So we want to go ahead and take a closer look at our support enforcer. And I'm just going to bring it lower than where the eyelet's going to be and take a look at what it does. So I did a pretty good job, except I'm noticing it's not adding support inside the lead weight chamber. So we'll go back to that here in a second. And now that I'm taking another look at the infill, you can see that it's not quite symmetrical. The pattern might cause an issue with weight distribution. So I'm going to go ahead and change the infill pattern from gyroid to grid. And while we're here, let's adjust our infill density to 20%. And let's reduce our print time by adding combined infill every 3 layers. Now let's go back to our plater and hit slice. This will give us a more symmetrical infill pattern, and that's what we want. So let's go back and fix the support enforcer. I want it to provide enough support material to fill the lead chamber. As you can see right now, it just doesn't quite make the cut. If we go back to 3D view mode, we can just rotate the support enforcer. Just rotate it on the Y. And then go to the scale tool. We'll just widen it out a little bit. Just enough to cover the lead chamber. And just take a peek in the back and make sure it doesn't cover where your screw eye is going to go. And everything looks good. Before we select our filament type, I just want to point out something that I noticed when I developed these lures. This lure right here I printed with PLA. It's one piece. Same thing with this one, same build, but I printed this one with PETG. Now when I shake them, notice this one has a high pitch. This one kind of crunches a little bit. Higher pitch, lower pitch. So maybe the density of the filament that makes that difference, but who knows. So I'm going to go ahead and select PETG for this lure because it seems to be stronger. And before we export our file, let's take a look at layer height. You may notice that I have mine set at 0.07 millimeter. That's going to give us a fine print, good amount of detail. It's also going to give us a 4 hour and 55 minute print time. And another thing to point out is they use filament in grams. At 0.07 millimeter, we're going to have 11 grams total print weight. If we change that to 0.15 millimeter, we're going to lose detail in our print, which may mean visible lines in our finished product, but we're going to save on print time significantly, and also material. In fact, it's almost a ½ gram lighter, which can make a big difference with small lures. So my advice would be, if you're prototyping these and you find a design that you like, you may want to keep that layer height. Let's go ahead and export our file, and it's going to create a Gcode file that we're going to use to print with. We have our prints done here, and I did 2 just for safe measures. But let's take a look at this one here. Even at 0.15 millimeter layer height, it looks pretty good. The supports here in the back, we'll have to sand those off. And the best way to remove the supports is to grab the body of the lure and break it. You'll be left with a couple stubs here on the belly as well as on the lip. We'll smooth those out with the Dremel. And now we want to get that support material in the lead chamber out. You can do this with a pick or needle nose pliers. It's kind of hard to get a grip on, but once you get a good edge on it, it all kind of just pops out. And we can go ahead and use the pick here to clean it up and get any other pieces in there out. Okay, looks pretty good. Let's go ahead and get ready to sand it. And I'm gonna use like a 240 grit sandpaper. I would use anything from 240 to 300. Let's put the bit on. I kind of like the wider diameter bits. I only had a small diameter, but it'll do the job. You kind of get bigger scores in your lure with these smaller bits. So let's take a look at these stubs here on the belly and on the lip. And let's try to clean these up a little bit. Put it on a medium setting and just lightly place it on top of each stub and give it a little bit of pressure while going back and forth. Once you get to the surface, the back and forth motion will be a little bit smoother. Try not to overdo it. You don't want to take too much off. Might speed this up. And as we work the belly, we're going to move our way up to the front. And to retain the shape of this lip, I kind of like to do it in one motion across. And I go with the flow, I don't go against the Dremel. You can go against the Dremel, but you're risking it. And so even with the rough job I did with the Dremel, it's looking pretty good. And I'm going to use this foam sand block to kind of just smooth out things here. I think this is a 400 grit. And once I'm done, I'm just gonna rub things over with my hand. If I don't feel any sharp edges, I think we're ready for our next step, which will be adding hardware and seal coating before airbrushing and finishing it off with a top coat. Thank you for watching and take care.